Greetings, math fans. All right, so this is actually going to be a really super quick lesson here, and we're going to just do a comparison of some ratios. So here is the question I'm going to say is what value is larger? Okay, that's pretty much the title of today's lesson. What value is larger? So what we're going to do is we're going to compare cosine of 20 degrees versus cosine of 21 degrees. Okay, so what you need you got to think outside the box with these problems. Don't just answer them really quickly. You got to think what's going on here. So first of all, cosine of 21 versus 21, or 20 versus 21. You remember cosine starts at 1, and then it goes to 0. So we're only in the first quadrant here. And, of course, if I would just kind of sketch it, right here's 20 and here's 21. 20 degrees, 21 degrees. Well, obviously, which one is going to be bigger? Which one's closest to 1? Is the 20 degree one closer to 1? So the answer to this one is cosine of 20 degrees. Okay? Make sense? And I could say sine of 20 degrees versus sine of 21 degrees. I'll say which one's bigger. Well, again, kind of the same idea. Sine starts at 0, it goes to 1. Okay? So, make a quick sketch here, right? Here's 20 degrees and here's 21 degrees. Which one's closer to the bigger number? Well, 21 degrees. So the answer to that one is sine of 21. All right. So that's not too bad. Let's do this comparison. Sine of 20 degrees versus cosecant of 20 degrees. Okay, so this one you got to do a little bit more thinking here. Remember, cosecant and sine, they're just reciprocal functions. So let's actually just compare, let's compare sine again. Okay, so sine is between 0 and 1. Well, you know that this is going to be between, since it's between 0 and 1, it's going to be a decimal between 0 and 1, right? This could be between 0 and 1. And isn't cosecant 1 over sine of 20 degrees? Okay, so if I do 1 over a number between, and we can't really use, I'm not going to use, in fact, let's be appropriate here. How about if I use a parenthesis? Okay, 0, because you can't be 0 because undefined. So 0 and 1. So it's going to be between 0 and 1. Don't you guys agree? If I do 1 divided by a decimal, isn't that going to be greater than 1? Right? So for example, 1 over 0.5, if I put that in my calculator, 1 divided by 0.5, that's 2. 1 divided by 0.1 is 10, right? So if that number on the bottom is smaller than 1, it's going to be a number bigger than 1. So I can now, when I want to circle which one is bigger, we know that cosecant of 20 is going to be bigger than sine of 20, because it's always, sine is always going to be between 0 and 1. It's always going to be a decimal, and then 1 over a decimal is going to be a number bigger than 1. All right, so that's why you got to think a little bit about what we're talking about, and think a little bit outside the box. How about if I do something relatively similar? Sine of 20 degrees versus secant of 20 degrees. Okay, now this goes with cosine, right? And it's actually 1 over cosine of 20 degrees. Well, remember, this is almost exactly the same problem, Because isn't cosine in the first quadrant, isn't it again between 0 and 1? So isn't this still going to be bigger, or it's still going to be a decimal for cosine? So 1 over decimal is a number bigger than 1, and so I can say that's going to be larger again. Okay? All right, now the hardest one of them all is this one. Tangent of 20 degrees versus sine of 20 degrees. Now that's a little more difficult because it's not like it's just a reciprocal where you can say, oh, it's, you know, it's larger, it's smaller. Well, first of all, we know that tangent is the yax, right, y over x, and sine is y over r. So if you actually think about that, now you can kind of do a direct comparison. Well, don't you guys agree the y's are the same? And what about the x versus the r? Well, isn't r always greater than either x or y? Isn't r the largest number? So r is the largest number. Okay? So if r is the largest number, let's just, let me come up with a random number here. If I said x was, let's say it was a 3, 4, 5 triangle. 3, 4, 5 triangle. And r was 5, so r is equal to 5. And x was equal to, let's say that was 4. Well, don't you agree that since that's the bigger number on the bottom, that whole ratio is going to be smaller? Right? It's always going to be smaller, that ratio, because r is always a bigger number. So if that is always going to be smaller, that means this has got to be the largest value here. So tangent of 20 degrees is going to be the largest because x is a smaller number. Okay, so I mean, let's compare it, right? The numbers I just chose, y over x is going to be 3 over 4, and sine of 20 is going to be y over r, which is going to be 3 over 5. And if you actually do a decimal, right, this is going to be 0.75. 3 over 5 is going to be 0.60, so this is going to be larger. Okay? So these are really good problems. They're not that necessarily that easy. You have to really think, compare the ratios to see what's true, which one is the largest number. Okay? That's it, math fans. You have a great day. Goodbye.